You want to learn how to create a simple ADAS visualization in CANape Option Driver Assistance in just a few steps? Stay tuned! Hello and welcome to this video. My name is Katharina and today I will demonstrate the steps needed to create a simple ADAS visualization. Please be aware that the features shown are only available with the CANape Option Driver Assistance license. First, let's open CANape. We will add a scene window and the ADAS Explorer to the empty configuration. The scene window displays your configured GFX objects, and the ADAS Explorer allows you to select which GFX object should appear in which ADAS window. Let's create a couple of GFX objects to see how it works. Either right-click in the scene window and select GFX configuration, or just click the GFX configuration button in the ADAS ribbon to open the GFX configuration dialog. Let's start on the left side of the window. Here is the data source selection, where all data sources that can be used for visualization are listed. If you can't find the data source you want to use here, check out the video linked in the description for more information. Next step is to create the GFX object by dragging and dropping the source from the left to the center of the window. Here you can select the type, coordinate system and other fun stuff. On the right side, you will find the properties of your created GFX object, and you can edit the color, size, position and much more. All these properties can be linked to signals, or you can insert fixed values. A GFX object can either be static or linked to data sources. First, let's look at the GFX configuration on the basis of a static GFX object. You can use static GFX objects to display the ego vehicle, indicate a sensor's field of view, or simply show a legend. GFX objects can be displayed in different coordinate systems. You can select Cartesian or spherical coordinate system. For the map window, there's a geographic option. We have also included view and image coordinates as pixel-based systems. Please refer to the built-in description for more detailed assistance. If the project has partial configurations, you can assign the GFX object to a configuration. The type combo box displays all the GFX objects available for use. Object types are grouped into 4 categories: 2D, 3D, driver assistance, and scene-specific. Basic shapes like rectangles, triangles, circles, and ellipses are available. You can also use complex objects like CAD models, road markings, and point clouds. For more complex use cases, you can create a code-based GFX object in C#. For many of the elements, there are mouse-over tooltips with more information. Documentation right where you need it. Basic GFX objects can be used in all ADAS windows. Specialized objects, such as point clouds or CAD models, differ from the standard GFX object types. They are scene-specific and can only be seen in the scene window. Now we'll configure our first GFX object, a static object of type CAD model in the Cartesian coordinate system. First, we navigate to the object file as a source for the CAD model. Next, we decide where to display the static GFX object. For this example, we choose the center of the coordinate system. Then the CAD model needs a display color. Let's go with red with a transparency level of 190. We can also adjust the size of the GFX object here to make it slightly larger. We also want to turn the CAD model so that it's pointing towards the y-axis. To do so, I set the special rotation to -90 degrees in the Z direction of the coordinate system. With hot reload, you can see the changes right away in the scene window. After clicking OK in the GFX configuration window, the settings are applied and the first static GFX object will be created. Now let's create another GFX object connected to a data source by dragging and dropping the source in the center of the window. When you link a GFX object to a data source, you can select one or more sources and combine them into a compound object. In this example, we will use smart camera detections as the only source. The detections should be displayed as a cuboid in a Cartesian coordinate system. A button links the parameters provided by the data source. In this case, the X and Y positions of the smart camera detection object are mapped as a base point. We choose a color for the detections, just as we did with the CAD model. We make the cuboid slightly bigger to improve visibility. Click Hot Reload to check if the detections are configured correctly. If so, close the GFX configuration with OK to apply your settings. As you can see, the sensor's coordinate system needs to be adjusted so that the detections are in the correct position relative to the CAD model. This can be set up in the ADAS system configuration. In this case, I changed the smart camera's coordinate system from the default to ISO. You can check your settings using the Hot Reload button. When the settings are correct, click OK to save. If you would like to learn more about the ADAS system configuration, watch the video in the description for a detailed explanation. Let's open a second scene window to learn more about the ADAS Explorer. It enables visualization of the objects in specific ADAS windows. All GFX objects created are available here and can be viewed in desired ADAS windows by checking and unchecking them. Once you have completed the camera calibration, you can also view the detections as overlays in video windows. That was a lot of information. I hope you learned something new. Thanks for watching. If you have questions, feel free to contact us at any time. Feel free to watch our whole playlist on ADAS features. There are clips for the 3 big windows in CANape Option Driver Assistance and about camera calibration too. Subscribe to the Vector Tech tutorial channel and see you soon. Ciao!